drugs that inhibit cell wall synthesis are penicillin, cephalosporin, carbapenem, and monobactam, which are combinedly called as beta-lactam drugs. Other drugs that inhibit cell wall synthesis are vancomycin, cycloserine, and bacitracin. So, if we go in detail of the mechanism, it is cycloserine. Cycloserine is a structural analog of D-alanine and prevent the addition of two-terminal alanine residues to the initial tripeptide side chain on N-acetylmuramic acid by competitive inhibition. Next, vancomycin. Vancomycin inhibits the release of building block unit from the carrier, thus preventing its addition to the growing end of peptidoglycan. Next, bacitracin. Bacitracin interferes with the regeneration of lipid carrier by blocking its dephosphorylation. Penicillins, cephalosporins, and other beta-lactams. Beta-lactams inhibit the final transpeptidation by forming covalent bond with penicillin binding protein that have transpeptidase and carboxypeptidase activity, thus preventing formation of the crosslinks. So, in this diagram, here we have a cell membrane. This area is inside cell membrane and this is outside cell membrane. So what happens inside bacterial cell is that the cell cytosol produces muramic acid, which has a tripeptide of alanine residue. This tripeptide combines with dipeptide, and this dipeptide molecule attaches with the tripeptide attached to N-muramic acid and forms a N-acetylmuramic acid pentapeptide. This pentapeptide of N-acetylmuramic acid gets attached to cell membrane having C55 lipid carrier by dephosphorylation. So when this phosphorylation of N-acetylmuramic acid pentapeptide have occurred, it gets attached to cell membrane with its C55 lipid carrier protein. Similarly, glucosamine goes dephosphorylation and gets attached to muramic acid pentapeptide, which is attached with C55 lipid carrier protein. So yeah, N-acetylmuramic acid and this glucosamine get attached. When when glucosamine and muramic acid get attached, a residue of glycine pentapeptide gets attached with the alanine pentapeptide residue gets attached at third position. This is 1, 2, and third alanine to third alanine glycine pentapeptide get attached. And when this glycine pentapeptides get attached to third position, the fifth position, the acceptor molecule outside the cell membrane attaches to this molecule. So when this another layer of acceptor molecule attacks, what happens? That this alanine residue goes off, and the fifth position of this pentapeptide, glycine pentapeptide, gets attached to this alanine of that next acceptor molecule. So what happens is that this, if you see here, the fifth position of glycine gets attached to the newer penta, fourth position of alanine of next layer of glucosamine of N-acetylmuramic acid and N-acetylglucosamine. So in multiple layers, this covalent bonding occurs. The pentapeptide of glycine, fifth peptide, gets attached with fourth of alanine, and by this a cell covalent bonding occurs, and here acts a transpeptidase enzyme which helps in attachment of binding of this cell membrane. So this is how our bacterial cell membrane is formed. And when this molecule of alanine gets off, the dephosphorylation of C55 lipid carrier occurs. Like this dipeptide converts to this diphosphoryl gets converted to monophosphorylation, and this is how a cell membrane is formed. So our drugs act on cycloserine. Cycloserine act at this position when the dipeptide molecule, actually cycloserine is an analog of this dipeptide alanine molecule, and it competitively inhibits the formation of this pentapeptide. If we call about bacitracin, so bacitracin inhibits the phosphorylation, the dephosphorylation of this C55 lipid carrier. So if this dephosphorylation does not occur, so what will happen is the like here the formation of this compound will not take place if it is in diphosphorylation form. So bacitracin inhibits the dephosphorylation of this C55 lipid carrier. Bacitracin acts at this, that is, it inhibits this alanine molecules to get out, to get off at fifth position, and beta lactams inhibit the covalent bonding occurring in between these two. Like here, this enzyme is inhibited by beta lactam antibiotics. So this was all about drugs acting on cell wall synthesis inhibitors. So if you are here, thanks for your presence. Hope to see you soon. Thank you.